Hi, I'm Krista, and I'm going to be showing you examples of machine learning in SAS. First, I'm going to be starting off in SAS Studio. This may be more for people who are familiar in SAS programming. Second, I'm going to be showing you the same model, but in Model Studio. This might be more interesting for people who aren't as familiar in SAS programming and are looking for an easier way to do it, but still want to have the same control over the hyperparameters. This video is more about showing how to do machine learning in SAS. So if you are interested in the fundamentals or why we're doing certain tasks, we do have a fundamentals in machine learning that you can refer to in another video. All right, so now I have SAS Studio open and we're going to go to the snippets. So underneath the SAS snippets, you can find a variety of different snippets that you can use. I'm going to be using the SAS Viya machine learning snippets. So I'm going to scroll down a bit. As you can see here, there are a few different options that you can use. You can compare two machine learning algorithms. You can even compare several machine learning algorithms. So if you were looking to use anything specific, all you would have to do is go to these little examples and maybe take that model out and use it with your data. So if you were looking to see how that was used, you can use these examples to kind of base what you're trying to do out of it. So right now I'm going to be using the supervised learning snippet. So this snippet is showcasing a sample machine learning workflow using the HMEQ dataset. So, and so what the steps of this are we're going to be preparing and exploring our data. So we're going to be loading it in, exploring it, seeing what missing values it has, partitioning it out, imputing those missing values, and identifying variables that explain variance. Next, we're going to be performing supervised learning using a random forest, and then we're going to be evaluating and scoring our model. Okay, so I'm scrolling down. The first block of code here is defining the macro variables for later use in the program. So what we're going to be doing is setting the output directory, so where we want our temporary files to be written to, starting our cast session, and then specifying the dataset name. So this is pointing to where our dataset is, and renaming it SAS data, cast data, partition data. Next, we're specifying the dataset inputs and the target variable. So we have our different variables here. So these are all class inputs. The ones below are the interval inputs, and they're all listed here. And then last, we have our target variable, which is the bad. All right, so if we want to get a quick look at our data, we can go to libraries. And scroll down, so it's in the SAMP SIO tab. I'm going to scroll all the way down till we get to the HMEQ data. So here I've already expanded it. You can see our different variables. There are 13 different variables. If we click on it, we can look at a sample of this data. So you can see a few different observations here. One thing you might notice is we have quite a few of these little dots. What that means is the data is missing for that variable for this observation. This is going to be important and something that we look at later. So I'm going to run this code. All right, so it successfully ran and we started our cast session. Now I'm going to be loading the data set. So we're loading the data set using the variable names that we set earlier. I'm going to submit and run. And that was successful. So we can see here that there are 5,960 observations and the 13 variables that we mentioned earlier. All right, scrolling down a bit more. This section is all about exploring the data and looking for missing values. So this is going to be telling us the percentage of missing values and which variables have the most. So I'm going to highlight and run this. Okay, so here we have a few different sets of information. We have the data summary, which shows us each of our variables, what level they are, so whether they're interval, class, and also if we scroll to the right, we can see the number of observations that they have that were missing. So out of the total data set, how many observations did that specific variable have that didn't have a value associated with it? We can also see the mean, the max, standard deviation, and a few other traits of our different variables. If we scroll down, we can see the percentage of missing values for each variable. So here you can see the depth INC is 21% missing for all of the observations. So there's a large amount of missing variables for this specific one. And we have a few other that also have quite a bit missing values, but we're going to handle them in a minute. But first, we're going to partition the data into training and validation. So we want to have our training set before we impute it because we don't want to mess with our validation set. So here we load in the data that we have, and we set our partition to be 70% of the data. So I'm going to run this. And that is complete. So here we can see the number of observations for each of the category for bad, and also the number of samples that we collected from each of those categories. So this represents 70% for this partition. So now we're going to get into imputing the missing values that we looked at earlier. So we have our training set, and we're going to take the variables seen here. So here we have 3, and we're going to impute those to the median. For these two variables listed here, we're going to impute them for the mean. And then we're going to save all this data in a data set with the tag prepped underneath it. So this is going to be used when we create our model. All right, so here what this generated is showing us how many variables we imputed and what method that we used. It also shows us the variables, their mean and median, so the value that was replaced when we did the imputation. So each of those missing values now have this value instead. So it's important when you're looking at data to make sure that what you're replacing is something that you should be replacing. There could be instances where you have a missing value where you don't necessarily want to replace it. It might just be another level in your data. So before you do this to your data set, make sure that this is what you really want to do, and this is changing it to be a more accurate representation of those observations. All right, so now that we've done the imputation, we're going to look and identify variables that explain variance in the target. So what this is doing is it's identifying variables that are predictive of our target variable. So what explains why this variability is occurring in our target. So we want to try and find those variables and limit the ones that don't explain variance so that our model can run on just the most predictive variables and not have any noise that might be associated with ones that are less predictive. So I'm going to select this bit of code, which also includes a plot that we can look at. So I'm going to run this. All right, and so what we have here is a few different summary information. You can see the proportion of variance explained by each variable. You can see the ones that were selected, and you can see a plot of the variance explained by each iteration. All right. So now that we've done this, we're finally going to get to building our predictive model using the random forest. So here we're using the procedure of forest. We're using our data set that we prepped earlier, and we've specified a few different input. So we have the number of trees being 50, the number of bends being 20, and the minimum leaf size being 5. So we have to specify which of our variables are the interval variables, which we have here, and then we named earlier in the program. We have our class inputs, and we have our target. Here we're specifying the partition that we did earlier, and then we're outputting fit statistics for the model that we create. So let's run this. Okay, here, so we can see a little bit of model information of the model we just created. So it's the same information that we put earlier, including some of the default values. So we have the number of trees being 50, we have the number of bends, the maximum depth, and we can also see the misclassification rate. So this is currently 12%. We also see the split of training and validation, and we can look at the variable importance that was generated by running the forest model. So you can see which variables were determined to be most important. This table is the fit statistics that we generated. So you can look at the training average squared error, the validation average squared error, and you can also look at those same things for the misclassification rate. So here you can see as we added more trees, so to the left you can see how many trees we have, that our misclassification rate for both the training and the validation went down. Now the validation never quite reaches where the training was at, that's expected, but we still have a relatively low misclassification rate at approximately 13%. Okay, so now what we're going to do is score the data using the generated model. So this is going to tell us how our data, or how our model was performing. So I'm going to select this code. And this is going to give us a plot of the misclassification rate per trees. So here you can see that as we're adding trees, we are getting a lower and lower misclassification rate until around this area, maybe like 18 trees, and we're kind of plateauing at this point. So there might be benefits of continuing. We might have what we see here, like a lower dip where we are getting a better rate. But overall, this is plateaued out, and adding more trees isn't really helping us much in creating a better predictive model. Next, we're going to assess the model performance, and we're also going to analyze the model using the ROC and Lift charts. So I'm going to select both of these blocks of code. And what this is doing is generating information related to the lift and the ROC. So here you can see various information for this partition, for the lift. Then if we keep scrolling, we'll also see the fit statistics. So what I'm scrolling down to is the plots it generated. So here we can see the ROC curve. So this is a relatively decent curve. We have it plotted the true positive rate against the false positive rate. So this looks pretty decent. The validation, of course, isn't as good as the training. If I scroll down a little further, you can see the lift chart. So this also plots the validation against the training. So that is it for the SAS Studio example. And now I'm going to be moving over to Model Studio to show you a similar model using machine learning pipelines. All right, so I'm in the SAS drive in Build Models. I'm going to go to Create a New Project. So I'm going to load our data set that we use in SAS Studio. So when you're trying to do this example, you'll have access to this data set and can just download it and import it the same way that I just have. I'm going to name the project example and start with a blank template. There are other templates that you can use, such as the basic template for class target or the intermediate template. This will start you off with a few different machine learning models. So if you want to start off with that, feel free, but I'm going to start off with a blank template that just gives me the data node. All right, now that we've opened our project and our data is loaded, it notifies us that we must assign a variable with the role of target in order to run the pipeline. So our target variable is here, named bad. We're going to switch its role over to target. Okay, so now that we've assigned bad to the target role, we need to change a few of the roles to their proper role. So based on the way that SAS reads in data, it scans the first few observations and then assigns what level it thinks it is. So in this case, it has assigned a few variables nominal when they should be interval. So I'm going to select everything but job that is nominal and change it to interval. So we have one more that I need to change. Deselect the previous ones first. All right. Okay, so now our data is how we want it. However, like we did in the previous example, we're going to want to impute those variables. So the way that we do it in SAS Studio is different from Model Studio. Here I'm going to select the variables that I want to impute. So I'm going to select 3 variables that we're going to change the imputation to be median. So that is this one, YOJ, and CLNO. So I'm going to change this, where it says impute, to be the median. So this is similar to what we did in SAS Studio, except all we're doing here is selecting the drop box. All right, for our other 2 variables that we set to the mean, that would be the CLAGE and the depth INC. All right, so we're going to change those to be the mean. All right, so now that we have our data like we want, I'm going to go over to the Pipelines tab. So the pipeline initially starts off with just the data node if you selected the basic template. So I'm going to expand the nodes on the left. All right, so we have the data mining preprocessing. So if you expand that, we have a few options for transforming or exploring your data. You can do variable clustering, selection, but we're just going to be dragging over the imputation node. So this is the node that actually imputes the data. When we set the features earlier, what we were doing is specifying what we wanted to happen when we had the imputation node in play. If you don't have the imputation node, this won't happen. So we have this loaded up. If you scroll down, you can see the class and interval inputs. These both have default methods that we're going to change because we've already set which variables that we wanted to be imputed and how. So I'm going to go ahead and change both of those to be none. I'm also going to select the summary statistics. So this is going to give us an idea of what it changed. It'll also tell you the number of missing observations and what they were replaced with. So I'm going to run the pipeline real quick. All right, so our pipeline has finished running. I'm going to open up the imputation node by right-clicking and selecting results. So here we have a few different tables. The first table is the input variable statistics. So you can see the number of variables that are missing. I'm going to expand this real quick so we can see it a little better. You have the number that are missing. You have the percent that represents in the observations that we have. And you also have the mean, standard deviation, and a few other features related to that variable. So I'm going to close out of this. Here you can see the imputed variables that we had selected. They now have a new name to indicate that we imputed them. They also show you the method that we use for the imputation and the value that it replaced and for how many observations that it did replace. Here's some other potentially useful information, but for now I'm going to close out so we can get to creating our model. So now that we've imputed our variables, I'm going to open up the Supervised Learning tab. So under this you can see a few different models available, but I'm going to create a forest like we did in the SAS Studio example. So I'm just going to drag it over and drop. You do also have an option where you can right-click on the node, and if you want to add something under it, select Add Child Node, and then go to the tab and you'll be given a list of things that would be under it. So if that's an option that you want to use, you have two ways of connecting new nodes to your pipeline. Okay, so here's our forest node. So we see by default it has 100 trees. We're going to change that to be 50 to match what we used in the Model Studio, what we used in the SAS Studio example. So here it just shows you different options. You have the tree splitting options, so you can specify what the class target criterion is. So you can change that. You can also specify the maximum depth, the minimum leaf count, so it's 5 like we had in our SAS Studio example. And you can also specify what to do with missing values. So this is just saying go ahead and use them in our model. All right, so now I'm going to run our model. Now I could have selected Run Pipeline, but I didn't in this case because we only have one model here, so the model comparison node wouldn't provide us additional information compared to just the results of the forest. All right, so now our model is ran. I do want to show one additional thing before I look at the results. So if you were interested in trying a few different parameters, you can go to the Perform Auto Tuning tab and you can just turn this on. And you'll have the same variables, except now most of them are in ranges. So if you were to run this, it would test out multiple hyperparameters and then present you with the top 10 models, which you then could use to determine how you want your model to be. So for this case, we just ran it once with the default parameters that we used by changing the number of trees to 50. So I right-clicked, I'm going to select Results. And here we can see a few different plots and tables. So this first plot here is the average squared error. I'm going to expand this to show you something similar to what we saw in SAS Studio. All I'm going to do is click the drop down and change the misclassification rate. So this is a similar plot that we showed there, but it also includes the out of bag and test sets. So this split into 3 different sets: training, validation, and test. And they're represented here and their validation, or their misclassification rate. So if you look, these are approximately the same as what we saw in the SAS Studio example. The algorithms may be slightly different, but overall you can see that it didn't make that much of a difference. So we have around 8% misclassification for the train, and we have around 11%, 12% for the validation set. This table here is the variable importance. So this was created when we ran the forest, and it shows you the importance of each of these variables to predicting the target variable. So this was also something that we saw in SAS Studio, but this is something that's auto-generated in Model Studio when you run your model. So you have access to all of this without having to add any code or run any additional code. It's ran automatically when you run your model. So now I'm going to switch over to the Assessment tab. And this gives us our lift reports and our ROC reports. So you can see the plots here. You can scroll down and also see the fit statistics. So this is all information that we created in SAS Studio, but this is automatically given to you when you run your nodes in Model Studio. So if you like this video and you want more tips like this, subscribe to our channel. If you want any related information, you can check in the links in the description below. And if you have any comments, feel free to leave them or questions. And thanks for watching.